Hello, hello, everyone. How's it going? Hi, hello. Let me do a bit of a setup. Let me remove the banner and just add some background music. I really love this one. Okay. Hi. How's everyone doing today? Hello. How's GHW been so far for you? I saw that there was a create your first recommendation system uh, stream, I think kind of yesterday, and with Jocelyn, and I think that was a very good one. Uh, from based on the description that I saw, I haven't seen the whole video yet, but based on the description, I think it was a very good one. And kudos for everyone who joined that, everyone who built the recommendation system. And welcome to the part 4 of Finance with Python. And what we have been doing is we have been learning about Python, but in terms and in context of finance. What that means for us is that we have been through some really difficult topics. I mean, to each their own, right? I thought they were really difficult. Some folks thought that they were really easy. So, yeah. And by the end of session 3, what we had achieved is we built something like not exactly completed, but we were looking into how do we download data from Yahoo Finance about Amazon, Google, and Tesla stocks. Then we did something called as RSI, which is Relative Strength Index. Spent a lot of time there. And before that, we made some OHLC, which is open, high, low, and close charts of JP Morgan, Apple, and Microsoft data. And then we also made some charts about candlestick charts. We spent some time understanding what does candlestick chart represent, uh, based on like what's the open, what's the high, what's the low, what's the close, what's the thickness of a candlestick. We had a very big discussion about the thickness of candlestick, which was a very good one, I would say. uh, yeah, we did so many things. And if you're joining me for the very first time and you are interested in all of this and you want to catch up really quickly, then in that case, let me offer you the GitHub repository. So the link is in the chat. That should give you access to the GitHub repository that I have been working with, I've been building, and it is available to everyone. I see that there have been like what 11 folks to it, 2 stars. I'm sad. If you like it, to star it if possible. If not, that's okay, perfectly fine. But 11 folks, that means at least 11 people are looking into this repository, probably working along with me, which is really nice, I think. Okay, so I think that's good enough intro to what we have done. To get set up for the very first time, you can follow this here. Okay, all of this, and that should get you started very quickly. Okay, once you have forked the repository, cloned the repository, then go through the README to understand what you need to actually run this repository, and that's it. Okay, cool. I think uh, that's good enough. Now, before we move ahead, may I kindly request all of you who are joining here to please register for the session. I've shared the link in the chat. Okay, so please do register for the session. It helps me, it helps you, it helps MLH, everyone. Okay, so please do register for the session. And apart from that, what else? Quick intro about me, because if you are joining me for the very first time, you're like, what is this guy talking about? So I am Utkarsh, but prefer to go by UT because that's how everyone knows me at MLH. Uh, so yeah, and I am a coach at Major League Hacking. I love to stream, so you'll find my streams in nearly every GHW stream. Technical content, like not exactly good in streaming, I would say, but I like to impart anything and everything that I have learned to people that can benefit from it, which is why I'm here nearly every GHW. I think last GHW I completed like 50, 53, or 55 streams, which is a significant feat, I feel, for me. Uh, yeah, so 50 videos are out there of me doing random stuff, teaching random stuff, uh, from the very basics of HTML, CSS, JavaScript to advanced like building full stack projects with like Node.js and React, doing bits of Python, doing bits of machine learning, doing bits of visualization, even app building using React Native. I think there's like too many of these things around. So if you benefit from it, definitely give a shout. If you think there's something that could be improved, there is a new feedback system which I'll share towards the end of the stream and would appreciate any feedback that you want to provide. I think that's a good enough introduction. And now let's get started because I'm itching to get started. Because there's so much to cover and so less time, I feel. So, hopefully, you have everything set up. I am going to start the Jupyter notebook from here. That opens. Once that is open, now this is the session 4. And even though I had done a teeny tiny bit of this session in session 3, I want to repeat it. So I'll create a new folder. I'll copy paste some of the things that we did in session 3, or actually rewrite all of it because I can give it a better structure, I feel. Uh, Once we as we start building, I'll also talk through a bit of theory. So that means you will hear more from me. Normally, when I talk theory, I come on screen. When I'm just coding, I go off screen so that you can focus solely on the code. Okay, so don't think that I'm gone. You can still hear my voice definitely when I'm coding, but I'm explaining theory. I use a lot of hand gestures, so that's why I love to be on screen at that time. Okay, so I'm going to click on new folder and session 4. Go in this one, new IPy and I'm going to rename this to session-4.ipy notebook. And we also always open it in Jupyter Lab because that's just a better looking UI, I feel. And if you're not a fan of light theme, definitely go for dark theme. I would prefer dark theme. The only problem is that based on my lighting conditions in the room and the weather outside, I would say, uh, it's not too much light on my face. So that's why I'm going with this one, which is too bright for me. But go for a dark one. Much better looking, I feel, to me. Okay. So let's move on to the next bits. So the next, as I said, I want to kind of uh, what do you say? Copy some of the things that we did in last session, but not exactly copy. So let me just start by doing it right here. So what we want to do is import a few libraries. So import pandas as pd, import matplotlib.pyplot as plt, import yfinance as yf. So yfinance is Yahoo Finance, and that is where you would get most of the data. So if I search for Yahoo Finance, and let's say I want the data of a ticker. In our case, we'll use the data of uh, Amazon. Okay, we'll use the data of Tesla, and we'll use the data of Google. So TSLA, Tesla, and historical data. And for last 3 years, That would be 2022 Feb till 2025. So this is the data that we will be working with. So if I keep scrolling down here, 9th of Feb 2022. So this is the exact data that we'll be working with, but we can either download it from here as a CSV file, or we can use the wait, which one is this? Close this one. Yep, there we go. Yeah. So we can either download it as a CSV from here, or we can use the Y Finance Python library to download data from Yahoo Finance. Okay. And we had installed this library in our first session. So that's why I don't need to download it. All I need to do is just import it for now. Next one is plotly.express as px and import matplotlib.dates as mdates, which we'll use later. Let me see if all these imports are successful. Yes, they are. You could see a quick star here. Sorry, a bit of a cough and a sneeze. Okay. Now, okay, all the things are imported. Now let's get into writing some code. Now, yesterday, let me show you what we had done. So towards the end of yesterday, we had actually written one function, which was to calculate relative strength index. Okay, and what is a relative strength index? We basically dived deep into it, but what it does, it measures the how far the price has moved and how fast over a 14-day period. So over like last 14 days, let's say, so initially there's like nothing for the first 13 days calculation, but over the last 14 days, what is the RSI? And to calculate that, there is a mathematical formula where we first calculate the average gain over a rolling window, okay, over like 14 days, 14 days, 14 days. And then we also find the average loss over the 14-day period. We divide that to get the relative strength, and to convert it to a numerical number, we use this formula, which is 100 minus, and in bracket 100 divided by 1 plus RS, and that should return a number to us between 0 and 100. Okay. Now, what does that value suggest? RSI more than 70, it suggests that the stock has been overbought. Okay, like lots of people have bought the stock and the price has gone very far up than what it should actually be, and there is a potential chance that it will revert down, it will go down, the price will go down. So if RSI is more than 70, it means it's overbought and there is a chance, there is a potential chance of the price going down. If the RSI is less than 30, then in that case, the stock has been oversold and the price has gone too much down. There is a potential chance that the price will go up. Okay, so that was what we discussed a lot. You can see yesterday's video where we actually go through these stocks and go through this data and actually check it out. For the time being, let me just start writing a bit of code and then we'll get to it, right? I'm thinking, should I do what I did yesterday or should I write it in a different way? Actually, let's do it in the way I did it yesterday. So we had stocks which are the three tickers that I want to use. So Amazon, Google, Tesla. Then we created a data dictionary. And for ticker in stocks, DF equals to YF, which is Yahoo Finance. Dot download ticker, period of like 3 years, and we want daily data, interval equals to 1 day. Because if you go to Yahoo Finance, actually, so this is the daily, but you can also have weekly and monthly data downloaded. So in our case, we are more interested in the daily data. Okay, so daily data. Then we are going to do a reset index with in place what we did yesterday. Let me just copy that. It's just easier, I feel. Okay, data dictionary. This is for holding the data. Then we did ticker in stocks, yf.download, period of 3 years, interval of 1 day, reset index in place true. So this is to ensure that the date is a column and the index column. Then the next thing was data dictionary of ticker equals to df, and we printed the head and the tail of the data. So this should do the trick. Let me run this one. So there we go. It downloads the data of Amazon, Google. Oh, I have a spelling mistake. GWGL is the ticker actually for Google. So this works, this works, this works. Okay, perfect. So all the data is now downloaded. Oh, not Google. Why do I keep writing Google? Okay, there we go. That's the alphabet price. Cool. Is it not? Why do they have two tickers? This is interesting. There's a NASDAQ real-time price, NASDAQ GS, for last 5 days. Okay, this has a chart for sure. And what about this one? This has a chart as well. Okay, interesting. Have two tickers going around. Okay, what's next? Let's write the RSI function again very quickly. So def calculate RSI. Series and the period, which we define as 14-day period by default. We create a delta, which is series.diff. We have done this yesterday, so I'm not going to explain each of it. Gain is going to be delta dot clip lower equals to 0. Loss is equal to -1 into delta dot clip upper equals to 0. Then we calculate the average gain. So average gain equals to gain dot rolling which is a rolling window, and the default window size is going to be 14. So that's why I'm passing it to period. But if you define a different window size, that's also fine. Min periods is equal to, again, the period. How many to be, the min periods is how many to consider during the rolling window. And average loss equals to, actually, I don't really need to do this. I can just do minus delta, right? Minus delta dot clip. Loss dot rolling. And again, window is period, min periods is this, and dot mean to find the average of it. So that's done. Relative strength is going to be average underscore gain divided by average underscore loss, and RSI is going to be 100 minus, in bracket, 100 divided by, in bracket, 1 plus RS, and we return the RSI, relative strength index. Perfect. And that's done. Next is, what's the next thing? I want to write a function called as compute technical indicators. Okay, I want to write a function called as compute technical indicators. A bit of a theory first. So let's focus on the theory. So compute technical indicators. This will actually compute the SMA 20, which is a 20-day simple moving average. SMA, simple moving average. And then we'll also calculate the EMA 20, which is the 20-day exponential moving average. Then we'll also calculate, we'll use this calculate RSI to calculate RSI 14, which is a 14-day relative strength index. Then we'll also calculate the Bollinger Bands, which is the upper and lower bands using the 20-day SMA that we calculated, 20-day simple moving average, and then plus minus 2 into 20-day standard deviation. Okay. Then we'll calculate the MACD, which is going to be moving average. Okay. Moving average, convergence, divergence. Yes, I think it's called convergence and divergence. And what else? What else can we calculate? Volatility. Yes. So 20-day rolling standard deviation is what we'll calculate, which will be our volatility. Now, if none of these terms make sense to you, don't worry. Let me first explain each one as we go along. So RSI, I told you about it. Okay, moving averages, which is SMA and EMA, simple moving average and exponential moving average. So these are used to smooth out the price data to identify trends, because price moves a bit up and down every day, right? So can we smooth it out in such a way that we can identify the trend of whether it's going up, whether it's going to go down, something like that. So SMA, simple moving average, it normally gives equal weightage to all data points. And EMA, which is exponential moving average, it gives more weightage to recent prices. Now, what does this mean? So let's start from the simple moving average because it's simple. Okay, so simple moving average, think that you have a box of chocolates. Yeah, think you have a box of chocolates, and every day, so every day's price is one chocolate in the box. Okay, so if you have price of 20 days, that means you have 20 chocolates, and what you do is you take the you take each chocolate and assign it the equal weightage, that no matter if it's a normal milk chocolate or dark chocolate, white chocolate, or I don't know, anything else that exists out there in the world, uh, you assign it a equal weightage of every day. You don't favor one over the other. and you divide it by, let's say, since 20 chocolates, to find the average, you divide it by 20. So you take weight of equal weightage of each of those, you take price of each of those, divided by 20, and that is your simple moving average. Now, what is your exponential moving average? So this is very similar. Like each chocolate will have some weightage assigned to it, and weightage is nothing but, you can think how important it is or how heavy it is. Okay, so like 1 gram chocolate, 10 gram chocolate, 100 gram chocolates. So that ways, in simple moving average, you don't consider, oh, one is heavier than the other. You were like, yes, everything is 1 gram, simple, or everything is 10 grams, uh, or basically you're going to average it out. Okay, but in exponential, you say that the ones that are recently added to your collection, they have more weightage than the ones that are old. Okay, so so what will happen because of the simple moving average will average out everything, so you'll have a very smooth line. But in exponential, because the recent things have more weightage, so they have a bigger say in the final average that is calculated. They will skew it depending on, oh, the recent ones have more weightage, and if they are going down, your overall trend will show that it's going down. If the recent one has more weightage and they're going up, your overall trend will show that everything is going up. Okay, okay, so why do we do this? Because, well, simple one, it is like everyone is equal. In EMA, that is exponential one, we are basically saying that the recent prices have more weightage because the recent prices show the current trend, like today's trend, yesterday's trend, tomorrow's trend, kind of like that. Okay, so, and we calculate this whole simple moving average and uh, exponential moving average, because without going through like daily slightly up, slightly down, slightly up, slightly down, we are checking what the trend looks like over like last 20 days. Is it a upward trend in last 20 days? Is it a downward trend in last 20 days? Okay, so that is your simple moving average and exponential moving average. Okay, so that's the first one that I want to calculate. So let me start by adding code for it. So def compute technical indicators, spelling mistake, technical indicators. They take in a data frame. We'll provide it a data frame. Uh, yeah. Now in the data frame, we'll create a new column called as SMA20. Okay, which is simple moving average of 20 days. And in this case, we will take the close price. So if you see in the data, we have date, close, high, low, open, volume. Okay, these are the things that we get in the data. What matters to us is what was the closing price. Did on the day end, did it close, like what, at what price it closed is what matters to us, kind of. We actually saw that the open, high, low, and close tell us if the overall there was profit on the day or there was loss on the day. Okay, we've seen all of this in the previous session. Sorry, excuse me. Yeah, so for us, what matters is the closing price. And next, so df dot, so we take the close price and then do a rolling window, rolling, not eoling, rolling, and window equals to 20 days, and then we find the average of it. Okay, that is our simple moving average of uh, 20 days, like which I explained. Now the next one that we want to calculate is EMA 20. And again we'll, oops, EMA 20, and again we'll take the close price, and this time we calculate the EWM. Okay, so EWM is nothing but the exponential moving average. and this takes in a few parameters. One is the span. So span is the number of periods to consider. So in our case, it's same as like window. So span is like 20-day period that we want to calculate. And next one is adjust equals to false. So by default, adjust is equal to true. We want to make it false. What is adjust? So uh, so adjust is for correcting any bias in the data, which it will like try to do it, but we don't want to because we are calculating the simple moving average without any bias correction, without in correction of. So bias is nothing but like, let's say one day price suddenly shot up, next day suddenly shot down, and then it was equal, like it was moving in a proper trend each day. Okay, so if there are any biases in the data, uh, you might want to correct them, but in our case we don't want to because uh, for simple moving average we're not doing that. Okay, so doesn't make sense to do it for something else. So that's the simple moving average and exponential moving average. Next one is the RSI. So I'll create a new column, RSI underscore 14 in the data, and we will call the function that we created here, calculate RSI. Okay, any questions so far? I was checking. Okay, nothing. Okay, calculate RSI. We will provide it the column, the close column, and we will stick to the default period of 14 days. Okay, the next bit. So this one, actually, let me add some comments here. So this one is trend indicator. This one is your momentum indicator. Momentum is how fast and how far. Okay, that is why it's a momentum indicator. The next one that we want to consider is volatility indicator, and this was RSI. Trend indicators, SMA and EMA. Indicator is Bollinger Bands. Okay, so before we go into writing code of Bollinger Bands, let's understand what are Bollinger Bands. Let me come back on screen. Yep, there we go. So Bollinger Bands. So the average weight that we calculated, the SMA EMA. Okay, so let's call something called, like, let's assume we have something like a average weight of the chocolates. Now Bollinger Bands are like two lines or two ribbons that are drawn above, like one above the average and one below the average. So now these ribbons are, you can think that they're very stretchy. They're like gum, they're like elastic ribbons. Okay, so they're elastic ribbons, and the more up and down. Okay, so actually no, so if the ribbon, actually think of it, if the ribbon is too wide, then it means that the prices are jumping around a lot. If the ribbon is too narrow, then it means that the prices are not jumping too much, they are like very calm. Okay, so the middle line, this average that that I said, it's the simple moving average, and the lines that these ribbons that we draw around them, they are usually uh, like, I think there's a distance there which is called like two times of the measure of how much the weights vary. So once you see the Bollinger Band, actually let me show you. Okay, think this should be good. So you have, so this middle part, that is your moving average, 20-day period, simple moving average. Then you have this upper band, this is your elastic, okay, stretchy elastic. And then you have this lower band, another stretchy elastic. And what it is, this, like, this is called as the Bollinger Band. Now it tells us if the price of the stock is bouncing a lot or staying steady. So in this case, if you see here, this is your simple moving average, but your Bollinger Band says that it moved up a bit, like a bit, a lot. Actually, even here, if you're doing this one day, and between the whole hour, like last 8 hours or something, let's say, excuse me about that. uh, so let's say on the same day, if you're looking at it, don't imagine that it is different dates, it is the same day, and you see the Bollinger Band, which is like, which has too many these turns, curves or something, that it means that the price is moving a lot, there's too much fluctuation going on. But if it's very smooth, like smoothly going down, smoothly going up, let's say, or even kind of straight along some paths, then it means that it is staying steady. Okay, staying steady in like the downward direction, staying steady in the upward direction. And too much movement can indicate that the price might change its pattern. If like there's too much movement going on, then now, and it was going like, let's say, slightly up, there is a chance then now it will go down. Too much movement going on, it was going up, chance going down. Okay, and then when it goes down, there was a calm here. Then too much movement going on, let's say here, then there's a chance of reversal again. Okay, too much movement going down, like going on here, there's a chance of reversal again. So there's a chance. Okay, so the price might change its pattern depending on what's happening. Is it too much movement? If the ribbons are uh, too smooth, or too uh, what's the word I'm looking for? It's like basically too much edgy. I don't know. No, not the edgy. Okay, I don't understand the word, but you can see this is the pattern that I'm telling, that there's just too much going on here versus a smooth pattern. Okay, so that's what Bollinger Band helps us determine. Now let's go back to writing some code for it. Another aspect actually I want to say is that how far or how wide. Hmm, Another aspect that I wanted to point out is the wideness. So if you see at some points, it is more closer to the average, and at some points, it is much farther away from the average. Okay. So, like at this point, if I draw a straight line, this distance would be much more, okay, than this distance, let's say. So, the wider the ribbon is, it means that again, there is, it's moving too much from the average. Like from the current average, it has gone up too much or gone down too much. And if it is very closer to the average, then it means that the fluctuations are less. Okay, that was another thing that I wanted to point out, how wide the things are and how uh, close the things are. Okay, so do remember that the wide means things are getting a bit wild here. Okay, uh, which means that there's just too much fluctuation, too much volatility. The prices are bouncing a lot, or if it is very close, then it means it actually stayed steady for that time period. Okay, and then you have your whole bouncing, too much edges versus calm, which is smooth. Okay, so those are also a few things to remember. Now let's go back to writing the code for it. So to calculate the Bollinger Bands, what we need to do is calculate the standard deviation. So I am going to create a new column, standard deviation, where we will provide it df of close dot rolling, give it a window of 20 days, and then calculate the standard deviation on it. Okay, so yeah, df of close dot rolling window standard deviation. Actually, for the ease of reading it, this is much better. Yes, df of close dot rolling window equals to 20 dot standard, which gives us the standard deviation. Then we will calculate the upper Bollinger Band. Upper Bollinger Band, and that is equal to, remember the column SMA 20, which was the simple moving average of 20, then plus 2 times of this standard deviation that we created of 20 days. Okay, and similarly, now the lower Bollinger Band, that is actually equal to the df of, again, SMA 20. So this SMA 20 is this one, and then minus, so lower, so minus 2 times of df of standard deviation of 20. Okay, so this should give us the upper Bollinger Band and the lower Bollinger Band. And standard deviation, we actually talked about it a lot in, I think, the first session. Okay, but very quickly, what is standard deviation? So standard deviation, if I, wait, let me think, how can I explain it very quickly? So it's a measure of how spread out the values are. Okay, and we saw that it is mathematically the square root of variance. Okay, so standard deviation, how spread values are, and it is actually square root of variance. What is variance? It is the average of the squared differences from mean. Okay, so if you find the mean somewhere, then the other values, so let's say if you have 1, 2, 3, this is the example that I used there before. So 1, 2, and 3. What is the sum of 1 plus 2 plus 3? That is 6. What is the average? So 6 divided by 3, that is 2. Now we calculate 1. How far is it from the average? So 1 minus 2 squared plus 2, the second value, how far is it from the average? So 2 minus 2 squared plus 3, which is the last value. How far is it from the average? The average was 2. So 3 minus 2 squared, that gives us 2. And then we find the square root of 2, which is 1.41. And that tells us that this is the standard deviation between them. Okay. So that's what we had used as an example. And now that's it. Yeah. That's what the standard deviation gives us. Okay, what else to calculate? Now we have calculated volatility, momentum, and trend. Uh, the next thing is MACD. Okay, now this one's going to be interesting. So Okay, coming back on screen, MACD. MACD is a moving average, convergence, and divergence. Okay, what does this mean? So, MACD is like having two averages, one fast average, one slow average. Okay, now what is this fast average, slow average, and how do you calculate that? So, before we go into how you calculate it, let's think about uh, we have two teams, okay, or at least, like, let's say two athletes, okay. One is a fast athlete and one is a slow marathon runner. In marathon you don't have to go really quickly because you'll get tired right? So you run at a slower pace, but you keep on running. And there's one fast athlete. So a fast athlete runs quickly for a short distance, which is like, the short distance is a period of 12 days. Okay. So example, so, or let's say 12 meters. Okay, in terms of athletes, let's not talk about days. In terms of athlete, let's talk about meters. So our fast athlete runs for 12 meters and then uh, gets tired and stops and starts, like, just catching uh, their breath. And the slow one actually runs for a longer period. Okay, example, 26 meters, like, keeps running for 26 meters, and that is your uh, and if, let's say, your track is 100 meters, so this fast one runs for 12 meters, stops, catches their breath. uh, the slow one runs for 26 meters, slowly and steadily. Okay, now in MACD you have one fast, one slow. How does this help us? So the fast one actually reacts quickly to any changes. Example, if it's not a straight line that the athlete is running, the athlete runs and then there is a turn, and since, like, this athlete stopped right before the turn, the athlete can take the turn quickly. Whereas the slow one is running at a pace, and the slow one is assuming that there is no turn, and then a turn comes. So it takes much more time for the slow one to kind of turn around. Okay, because the slow one is at their pace. Okay, so uh and that's it here. That is the fast average and the slow average. So technically what happens is, in MACD you make this line, which is your fast average or your slow average, and you make a signal line. Okay, and what happens is, whenever the MACD line goes above the signal line, it means that you can buy the stock. And when it goes below the line, below the signal line, there is a possibility that, this could go down. So it's a chance, it's an indicator of selling the stock. Okay, so we are going to use two exponential averages. Exponential average, we know what exponential average is. One would be a fast exponential average, like a 12 day, or calculated over 12 days. And one would be a slow one. Okay, slow exponential moving average, which is like a 26-day average. And once we have both of these, we'll have a mathematical formula which we will use to actually calculate it. Okay, and yeah, I think that kind of explains most of the things. The idea, as I said, is to compare the two averages. Okay, these two averages, this fast one and slow one. And depending on what is happening, if it's going above, if it's going below, it tells you should you buy or should you sell. Okay, yeah, I think, does that sum it up? Anything? Okay. Uh, so again, to sum it up, fast average calculated over shorter period reacts quickly because it gives, remember, EMA gives importance to the weight. uh, like recent weights get more importance. So, and this is a shorter period, so you will have a fast average there and a slow average calculated over longer period. And depending on how fast and slow things are and how up and down they are going, it can indicate should you buy some stock or should you sell it, because chance of going up or going down. Okay? Let's write the formula, and I think that should start making much more sense. So a comment here saying MACD. Okay, so we first create a new column, EMA12, exponential moving average of 12 days, and that is equal to DF of closed price dot EWM, okay, exponential moving average, and the window would be of 12 days. We are not going to adjust anything, like not adjust any bias, and then find the average of it. Similarly, right after that, let's also calculate the DF of EMA 25, okay, 26, sorry, by 25, 26. DF of close dot EWM, and span is 26. So 26-day period. Why did I write space here? Span, span, span. Yes, 26-day, sorry, period. Uh, adjust equals to false, not adjusting any bias, and find the average. And now we'll create a new column, MACD, and that is equal to the DF of EMA 12, which is the fast moving average, minus the DF of EMA 26, which is the slow moving average. And now we'll create a new column called as MACD signal, and this needs to be in double inverted comma, and that is equal to the DF of MACD. So this is the signal line that I was talking about, dot EWM, so exponential moving average on that, span equals to 9. Okay, so over a 9-day period, not going to adjust it and find the average of it. So this creates the signal line. Now our MACD, if our exponential move, like MACD line, if it goes above this signal line, then it means that there is a chance to buy. Like there's a potential uh, that if it is going above this line, that means that the price will increase and you should buy it. If it's going below this signal line, then it means that the stock price might fall and you should sell it as soon as possible. And again, this is an analysis. It does not mean that this will happen. They depend on a lot of different factors. Okay. Uh, but yeah, for the time being, I think this is a good one. What next? What next? What next? Okay, so the next thing that I want to do is show return distribution and correlation. So return means how much has the weight of our, let's say, chocolates changed from one day to the other. Okay, and the distribution is like seeing if this is the same change, like the weight has changed in a similar fashion, or if there are days where it changed too much, or and if there are days that it changed too less. Okay, so this would be a percentage calculation. And a correlation is basically like telling if between two different things, between two different uh, boxes of chocolates, if the trend is the same, if they're changing, if they're increasing in weight in the same manner, or if they're decreasing the same in the same manner. So if the high so high correlation, what does that mean? So it means that if one of the box of chocolate changes weight, like if there are two boxes of chocolates and they have high correlation, it means that both of them are going to, like, are getting heavier, or the size of the weight of the chocolate is increasing in the usual fashion. Okay. uh, and both of them will be having, like, move changing at the same pace. So either both of them are getting heavy, both of them are getting lighter, or the other option is a low or a negative correlation. This means that uh, if like one of them is increasing, the other one could be decreasing, so there is no correlation between them. Okay? So that's what we want to calculate, uh, the return analysis and the volatility. Okay, very simply put. So let me write the code for that one. Okay. uh, I can plot the correlation later. Yeah. Okay. So for the timing, let's just do a percentage check. Df of close dot percentage change. Okay, how much things are changing, and the volatility of 20 days. And that would be over the return column. We are going to do a rolling window of 20 days, and then finding the standard deviation. And we'll drop all the NA. So df dot drop NA in place equals to true, and we'll return the data frame. I think this one was a big code, definitely. And let's run this. Okay. So these are the things that we have calculated. We can do the correlation using correlation matrix if we want. And let me actually take this bit. I'm removing this one. Okay, so from the very top, we imported all the libraries. Then we wrote the calculate RSI code. Then we wrote the compute technical indicators code. And now I'm going to paste the stocks thing, data dictionary. Uh, don't want to see the first 10 rows of anything or the last 10 rows of anything for the time being. Right before this one, so we do for ticker in stocks, then we download all the data, then we reset the index, and now, right after this, let's compute technical indicators. So our technical indicators actually also calculates the RSI. Where was it? Yeah, right here. Okay, calculate RSI. So this should have everything technically. So I'm going to do replace the DF with the compute technical indicators of the DF, and then assign it to dictionary and print the data. And actually, let me also print \n data \n and df, okay, right before the return. And I'm going to remove these two for the time being. Okay, now let's run this one. Downloads all the data. Okay, that's good. Oh, oops. Let me run this, and this. Okay, so this is what we get. Let's see one of them. uh Actually, let me just run the df right here. Why have a df? We have a data dictionary actually. Let me run the data dictionary of AMZN. Okay, Amazon. So this is what the data looks like of Amazon. Uh, there's a closing price, the high, the low, the open, the volume, and then we calculated these values. SMA 20, okay, that is the simple moving average over last 20 days, exponential moving average, the relative strength index, the standard deviation, the upper Bollinger Band, where should that go, the lower Bollinger Band, where should that go, exponential moving average over 12 days, exponential moving average over 26 days, the MACD, okay, the MACD signal, the return, and the volatility 20. Okay, so these are the values that we have calculated. I think when we actually plot this one, okay, that's when we can visualize it much better. So let's write the first plot, which is plotting the technical analysis. Okay, I think that could help a bit better. I'm going to remove the print statement from here and run both of these. Okay, now let's write a function to f plot technical analysis. Df comma picker, it will take in two things. Then plt dot figure, and we can define a fig size here, right? So fig size equals 20,8. Okay, that should be a big enough figure. Plt dot plot, uh, what all columns do we have? We want to plot the date column. Okay, then we want to plot the close column. Then we want to have a label equals to close price, and let's give it a color of black. And I'm going to copy this line and paste it two more times. The next one would be plt.plot date. We want to plot the SMA 20, simple moving average over 20 days. And the label would be 20-day SMA. Okay, color would be, let's say, blue, and the line style, I'm going to use the dotted. Actually, let me copy this one and replace it right here. Date, and this would be EMA 20. And this would be 20-day EMA. Color, let's say red, and line style this. And let's just plot this one. Would it make sense? Actually, we should also plot the upper and lower Bollinger Bands at the same time. So plt dot plot, and this time let me copy whatever is inside this right here. So df of date, df of the upper Bollinger Band, that is a column, and label would be upper Bollinger Band. Color, let's say go with green, okay, and the line style is different. And right now we can copy this one for the lower Bollinger Band. Okay, so date, and the column name is lower Bollinger Band, and this side label would be lower Bollinger Band. Color, we can keep it green, uh, or orange, let's say. Line style is this, and that's it. Now we can give it a title, plt.title, and we can use f strings to actually give it a title depending on the ticker that is being plotted. So ticker technical analysis, okay. On the x label, on the x side, y index, y line, x line, what's it called? On the y side, it is basically the price and in dollars, because all of them are US stocks. Then we also want to show the legend so that you can see it. Let's add the grid as well. And what else? Okay, on the current axis. So we can use something called as .gca, which is get current axis, .x axis, dot set underscore major underscore formatter. And you remember that M dates that we used? So set major formatter, it is going to set the date format, and inside this we will use the M dates that we have imported, dot date formatter, and we will format the date in the style of percentage y, which is the year, then dash percentage m, that is the month, and then dash percentage t, which is the date. Okay, and now on the x line, we want to set the rotation of whatever is plotted to 45 degrees. We'll use the tight layout so that there's not much flowing here and there. So what this happens is it automatically adjusts the subplot so that they fit inside the figure area. Okay, it's not flowing outside or something, or it's not cutting off. Okay, and now plt.show. Okay, I am going to actually take this out from here, put it here. We start right here. This is done, this is done, this is done, this is done. All that, everything has downloaded. Now what I want to do is create a Tesla DF. So Tesla DF, and that is equal to, from the data dictionary, I want the Tesla key. Similarly, I want to create a Amazon DF, AMZN underscore DF, and from the data dictionary, we want the AMZN. And third thing that I want to create is going to be the Google underscore DF, and from the data dictionary, we want the Google column. Okay, so all this is done. It's coming from the data dictionary, which is good. Uh, Now let's plot the technical analysis. Okay, so plot technical analysis, and first let's give it the Tesla data frame and the ticker, okay, for the name. And let's run this. There is one error. It says that it has no attribute xtick. I think it's called xtick. Okay, yeah, xticks. Okay, perfect. Now look at this. So the closing price, it's in the black. Okay, let me come back on screen, and then I can explain it better. So the closing price, that is in the black. Okay, perfect. Look at the 20-day simple moving average. It moves very closely to the closing price. Okay, focus on the black line here. So this is your closing price. The 20-day simple moving average, it's in blue. Look at that. So the black line moves up, simple day moving average kind of moves up. Then the black line goes down, simple day moving average is kind of going down. Okay, uh, cool. The 20-day exponential moving average, okay, it kind of follows the path. There is slight deviation, okay, right here and there. Okay, the slight deviation between the 20-day uh, exponential moving average. Now look at the upper Bollinger Band. So that is the standard deviation from your simple moving average and how up and go down it is going. So in that case, this is the movement that is happening, and the lower Bollinger Band is right here. You know what? I can plot one thing at a time. So if I run this, I don't have to run this, and run this. Okay, so this is just the uh, price of Tesla. Okay, the black line, perfect closing price. There's nothing else to explain here. Up, down, and this is your trend normally of based on the dates. Okay, now let's just plot one thing, which is the simple moving average. Simple moving average, just the blue line. So you see the black line going up and down, and the simple moving average, which is calculating the average, and it is not taking into consideration the recent prices or anything. It is moving in this particular fashion. Let me remove the original price, okay, and let's only work with the simple moving average. This is the simple moving average of Tesla. What was the simple moving average? Over a 20-day rolling window, based on the close price, we are calculating the average. Okay, now let's check the simple moving average with the exponential moving average. These two. Okay, 20-day exponential moving average. What was the exponential moving average? If you remember, it was the uh, over 20-day period. We are calculating the exponential moving average where we assign like the recent ones get have more weightage. The recent prices have more weightage and the old ones have less weightage. Okay, and you see this is what the calculation and the chart looks like. Okay, so nothing much. You do see slight differences. So when simple moving average said that, oh, it's going up in a like it's going up in a smooth fashion, the simple moving average said actually not. Okay, instead of these double dot, let me make it a single line. Probably that would also give a smoothing factor. So when simple moving average said that, you know, there is not much change, it's moving down in a straight fashion. Okay, moving up a straight fashion, moving down in straight fashion. The exponential moving average said actually not. There is some slight breakage here, okay, which means that it was falling sharply here. Then it smoothened out a bit. Okay, so that is what these two lines are showing us. Simple moving average said it's moving up in a smooth fashion, and now it's going down. The exponential said, actually, no, you know what? Actually, there is a sharp fall here because over the last 20-day rolling period, I see that, and by assigning more weightage to the recent data, I see that it's actually going for a sharp fall. Okay, so this is good. Now let's go with the Bollinger Bands. Okay, the upper one, just the upper one. So this is the upper Bollinger Band. So upper Bollinger Band, what it does is, yeah, over the simple moving average, it calculates the standard deviation, okay, over the rolling 20-day rolling period. But there is this 2 into df, which is for giving it the distance. Now look at this. How far is it from the simple, the blue line, and how close it is to the blue line? That's what we want to figure out. So I will remove the exponential line for the time being and only focus on the this one, simple moving average and the upper Bollinger Band. So what's happening here? So there's your simple moving average, there's your upper Bollinger Band, and it says that the distance between these two is higher. Okay, as you can see, that the distance between this point and this point is too much. There's a thickness in the Bollinger Band. Okay, and this one is closer to the simple moving average. So what did the distance indicate? So the distance between the ribbon, it says that the prices are jumping around a lot. Okay, so wider it is, the prices are jumping around a lot. The narrower it is, so this is very close, it means that there was not like over the simple moving average, the price is not jumping around a lot, things are more calmer. Okay, at this point, if I try to draw a straight line here, prices are jumping around a lot. But at this point, it is a bit calmer, not much jumping around. Okay, so let me get this one back, the actual pricing. Okay, so over the last 20-day period of simple moving average versus the price here and the upper Bollinger Band, let's see. This is where the upper Bollinger Band is. This is where the simple moving average is. And look at the actual price. There was a very sharp uptick and a very sharp downtick. Okay, that happened here. Now, where else? This distance is closer. Look at the actual price at that time and the simple moving average. Simple moving average said that initially there's a downward trend and there's a slow, like there's a calmer upward trend. Okay, not much jumping around. Bollinger Band said, okay, yes, looks the same. And look at the actual price at that point. There is a slight up, down, up, down. This, like, if you see this change, like if I draw two lines at this point, this change is not much in terms of like the pricing. It would be like a few dollars up and down. Okay, not a decline like from 390 went down to 200. Okay, 390 or something, and this is what 210, 220. Not like a sharp fall or a sharp uptick. So that's what this one shows us. Now let's see what about the lower Bollinger Band. I'm going to remove this one. So between the upper and lower Bollinger Band, okay, let's see this distance, see this distance, see this distance, see this distance, distance. So the wider the gap is, okay, the wider the gap is, that means that prices are jumping around a lot. The shorter the gap is, that means things are calmer. Now, what about the gap between the upper and the lower? Okay, what does that tell you? So right now we were checking that how far it is from the simple moving average. Now look at the upper Bollinger Band and the distance between upper and lower. Okay, at every point. Looking for any questions. Oh, there's one about source code of the full thing. Okay. Okay. So, okay, I will push this. So now the upper Bollinger Band, it was like we saw what's happening there, and it is like the moving average plus two standard deviations. The lower one is the moving average minus two standard deviations, and the distance between the two, it is like distance between the two bands and the moving average is the standard deviation. Okay, how far it is deviating from the average. So at this point, there is a sharp uptick and the sharp white out downtick. Okay, so let me think of an example which would explain it in a much better format. Mm, Thinking of ribbons and chocolates. Like, give me 1 second. Okay, so now the distance between the upper one, the lower one, okay, it is less here. And what about the distance between the upper one and the lower one here? This is a lot more. So check this one versus check this one. So in this case, it said that the price actually jumped around a lot. Now let me introduce the actual price in the plot. So focus on this aspect. There is this one, and if I try to draw a straight line somewhere, okay, from here to here, okay, from where here it is where it is going to come. So this distance plus two standard deviations minus two standard deviations. So absolute, if you take the absolute value, it would be like four standard deviations. And it says that the price actually jumped a lot between this point and this point. And can we see this? Kind of. You see that the price actually went a sharp uptick and there is a sharp downtick. This is where it ended. This is where it went. This is where it ended. This is where it started from. Sharp uptick, sharp downtick. So that distance, so the wider the distance between these two bands as well is how much the prices are jumping around. There's just too sharp uptick, too sharp downtick. Now, the shorter the distance between the two bands as well, the upper and the lower, then it means there was not much jumping around. And let's compare it with the actual price. You see, it was slowly moving down. It remained nearly same here, maybe $5 up and down, slowly moving down. Now this distance started increasing here, and we see that with the actual price. Sharp down, sharp up. Okay. Then look at the price here at this point. At this point, it is $1 up or down. Look at the distance here. At this point, the distance is too short between the upper and the lower Bollinger Band, which means it was calm. It was really calm. Okay. So when I had initially said that only look between this and this, if you see the distance between this and the distance between this and this, it's like nearly flat. So it helps in checking the upward check. Like you could have focused on the like you, we focused on the up only on the upper and the simple moving average. Then we check the lower and the simple moving average. I hope we did. And then finally the distance between the two. So the wider this gap is, that tells you how much is the price move, and we have the actual stock data here as well. So now let's see this point and this point. These 2 points suggest that there is a huge gap between the upper and the lower. Okay, and if I remove the this one, mm, SMA for the time being. Okay, so I remove the SMA for the time being. So now focus on the distance between, where was it? Yeah, this point. Okay, at this point, this gap is huge, whereas this gap between the green and the orange is really less. And we see that in the price, that the price was actually kind of moving just, maybe a dollar up and down. It was still a very calm phase, but this height suggests that there was a sharp uptick. Okay, and that's what we see here. This gap says that it was going up, and now this gap has increased between the upper and the lower, and there is a sharp downtick. There we go. This one is, the gap is relatively smaller. And what does this show? It shows that there wasn't much change in the price. Okay. This point, this point, there is a sharp, like there's a very wide gap. So there is a sharp change in the price. And as we move up, we can see up, down, this height, okay, much more than whatever was here. Example, so this height versus this height, sharp change. Okay, so this height, sharp change again. So that is our Bollinger Bands. Tells you overall if there has been too much movement in the price or too less movement in the price. And looking at that, we can kind of check out for any technical indicators about price reversals and stuff. Now let me plot everything together. So this one's done, this is done, this is done, and there we go. Okay, Bollinger Band, the actual price, the simple moving average, exponential moving average, and yeah, stuff. Now what's next? Uh, okay, there is an ask for this whole code. So let me actually add that. Did I save this? Yep, saving completed. Git add all, git commit dash m feature added RSI. What else did we add? RSI, technical indicators. And what else did we do? Plot technical analysis. Okay, so now you should actually have the code for everything that I did. Nice. Oh, session 4. And I'm going to git add, git commit dash amend, and git push with force because I made a change in the git history. Come on. Git is very weird here. Okay. Sorry, give me 1 second. I'm trying to ensure that it comes down rather than going up. This should change the name. Okay, perfect. Now if I rename this to session 4, okay. Yep, perfect. So session 4 right here. So this should have everything that we did till now. Okay, up till the moving average. Cool. Before we move ahead, did all of this make sense? Any questions so far, anyone? The next one would actually be about plotting the MACD. Okay, so we plotted the technical analysis, all the technical indicators that we calculated. The next one would be plotting the MACD and the signal line. Okay, the whole code is now available on GitHub. Let me share the link in the chat. Okay, I'm going to take the silence as golden. Hopefully, the widening thing made sense. The simple moving average made sense. Like over a window, it's more of a softer thing. The exponential could be sharper because it's over uh, like it gives more weightage to the recent prices. Yeah. Okay. The next one is plotting the MACD. Let me do that. DF comma ticker. That's what it would take. Uh, and we can directly go into plotting because we have done the calculation. Okay? It's in our data frame. So plt dot figure, and I'm going to actually copy whatever we wrote here. Takes most of my headache. The only difference is instead of plotting these many things, what we want to plot is uh, date, yes, and then MACD. Label would be MACD, and color we can go with magenta. And the next one would be date. MACD signal is what we want to plot, and the label would be signal line. Color we can go with orange. Don't really need the line style. And the title, ticker, and MACD signal line. Then this would be date, and the Y label would be MACD value. We want legend, we want the grid. We don't have to format this one, or actually, let's say commenting it for the time being. Xtext rotation, tight layout, and plot.show. This should be good enough. And now let us actually plot it by calling the plot MACD, giving it the Tesla DF and the ticker. Uh-oh, I made a mistake here about what it says. MACD signal does not exist. What did I name it above? Oh, my bad. MACD signal. Oops. We'll have to rerun everything. Okay. So this is our MACD and the signal line. Okay. So what was MACD? Let me come back on screen. So what was MACD? MACD was moving average, convergence, and divergence. So it is like having, as I said, two lines. One is a fast moving average and one is a slow moving average. Okay. And what we do is subtract the difference, like subtract the slow average from the fast average. And this is the MACD line. And then the signal line is like another average, like a smooth average of the MACD line. Okay. So MACD line is fast average minus slow average. And the average is of MACD is the signal line. Okay. Now, when the MACD line, okay, which is the fast minus slow, if it goes above the signal line, let's check the places where it goes above the signal line. Remember, signal line is orange and MACD is the magenta slash pink, whatever. So anytime the MACD line goes above the signal line, it is like a sign to buy. And whenever the MACD line, which is this pink, goes below the signal line, then it is a sign to sell. Okay. Now, let me try and add the closing price to the mix. Okay, there we go. And now let's focus on this. Anytime the pink goes above the orange, so at this point, the pink went above the orange, like it is above at whole of this point, and that is a sign to buy because the price might go up. Look at the price. Okay, the price might go up and it is going up. Anytime the MACD line, which is the pink, is less than the like it's downwards toward down from the orange. Okay, that is a sign that the price will go down. The price is going down. Again, pink above the orange, the sign of price going up. Did not go much up. It is just like right there, up and down, a bit here and there. Does not make much difference. Let's come towards the end. Like this is the most recent price. This is like 1st Feb to 7th of Feb, which was like 2 days ago. Pink line, which is the MACD line, going down from the signal line. This is a sign of selling. Okay, like not a sign of selling. This is more like the price might go down, then should sell your stock because it stands that the whole price will go down. Okay, so pink line below this, chance of selling, and we do see a downward trend happening. If this continues, like you see this, you can make a decision. Like this is still 7th of Feb, this line is still down. Should sell probably your Tesla stocks because it's chance that it might go further down. But this is more of a technical analysis. This is more of an assumption based on what we have seen in the past. On Monday morning, it is quite possible that there is some new news and it shoots up. Okay, but from the trend, it looks like right now selling the Tesla stock would be the best idea. Okay, at least that's what this data suggests. Let me try and plot this whole thing for Amazon and Google. Okay, plotting the MACD for Amazon and Google. This is the Amazon one. Okay, again, look at the pink and the orange. They are like really close to each other. So it is very difficult to make a decision. That is why there is a steady change in the price actually. Only at this point, there was this very sharp decline. And we see that the orange line is signal line and the pink line went actually down from here. Okay. So this is not a future prediction. This is more of a past data. And we can see that, we can see what happened here. But at these points, it's very difficult to make a decision. I can, let me like remove the stock data, and this gives you a much better view of how much things have changed. So now the recent data, orange line, this is above, the pink is above, so buy probably. But at this point on like the closing day, the pink actually goes down. So maybe on Monday the price will probably go down from for Amazon. Okay. probably. And let me do that same for Google. Okay, sorry. Okay, sharp downtick. Chances of it going down on Monday? Probably. In general, I see that the orange and the pink have been kind of going up and down here. Okay, signal line, MACD line, and this is where it is. Okay, so does this make much more sense now after the graph? Any questions, anyone? Okay, I'm going to, it makes more sense now. Okay, perfect. Thank you so much. Really appreciate this comment. That it makes much more sense now. I, I think I should have waited for everyone. Like I should have waited for the plotting of graphs when it would start making much more sense. Graphs make much more sense in general, I feel, right? Uh, okay, so this is done. We have plotted like three MACD lines. You could also plot the technical analysis for all of them. So right below this, let me also plot the technical analysis of other two. This is fine. This is fine. And plot technical analysis. One would be Amazon DF with Amazon, and the next one would be Google DF with Google. Okay, run this one, run this one. Okay, perfect. Bollinger Bands, simple moving average, 20-day moving average, and the actual price. Okay, and the MACD for all of them. You can plot it in a single one as well if you want. How much time do I have? I have like 20 minutes. Actually, I have another session right after 1 hour. No, not right after this, after 1 hour. So I can continue for the time being. So the next one is returns distribution that we want to plot. So you remember the return column that we created, which is right here. Yes. So that is the percentage change between each day's closing price and the, yeah, that's what we want to plot actually. Hmm. Okay, let's try that. Let's create a def plot returns distribution, takes in a data dictionary. So we'll give it the whole data dictionary. So we'll plot a histogram of daily returns for multiple stocks to show how distributed was it. Okay. So if it is a normal distribution, okay, a Gaussian, a bell curve, what we call, then it means that it's a random walk. And what is random walk? We discussed this in second session, I think. Uh, and this is why I have this normal distribution open. So random walk means that the price of the one day depends on the next day depends on the price of the previous day, and it is random. Okay, it is very random, uh, and that's why we find the cumulative sum and everything. But if there is a fat tail, okay, which it means that there is a chance of uh, extreme events happening. Let's plot this. And I think then it would start making much more sense. PLT dot figure fig size equals 10 comma 6. So now we'll loop over everything. So for ticker comma df in data underscore dict dot items. So we are looping over data dictionary. We are getting the key and the value. The value is the data frame and the key is the ticker name. I'm going to use the histogram plot. So plot dot hist, and we'll take in the return. Then the bins is 50. Alpha is 0.5, and the label would be the ticker name and the density would be true. And what next? I can copy some things from here. Okay, so this and the plot title, of course it won't be MACD, it would be distribution of daily returns, right? Distribution of daily returns. The X label would actually be daily return in percent. The Y label would be the density. Legend, yes. Grid, true. No, I don't want this. This is fine. Okay. So to plot the distribution, we have to give it the whole dictionary. So we can take this one, and actually our dictionary is also called data dict. So this should be fine. Now if I do this, okay. So spelling mistake. Distribution. DUTIO. So distribution of daily returns. Now let's see this. So the blue is basically the Amazon stock, the orange is the Google stock, and the green is the Tesla stock. The daily return percentage. So this is a, you can think that this is a correlation between them. And if you see, the correlation suggests that they actually are in the bell curve, which means that most of the things are actually following the norm of the market. Okay, most, like all the stocks. When, like, there were days of no returns, uh, they were like, they were basically following the trend across the whole market. But then there are these additional things, like there is this one Amazon uh, bar right here. Okay, let me actually go away from screen. I don't think it's visible. Okay, now it should be visible. If I zoom in, there's one blue bar here. Okay, and there is some green bars here. Similarly, there are a few green bars here. Okay, so this suggests that there were a few days where the Tesla stock actually broke out of the norm. Okay, and either gave a positive change or negative. Here it fell down sharply, Amazon. Did not follow the market. Here it rose sharply. Did not follow the market exactly. But generally, the trend was that it was following the market. Okay. Right here, Tesla is much more on, like, going down side. Right here, it was going up a lot. Okay. The distribution of daily returns. How much is the percentage change between the days, and is it following the normal distribution? And this is, if this is a bell curve, as I said, it follows the normal distribution, which is a random walk. Okay. Price of next day depends on the price of previous days, cumulative sum, all those things. Check out the video of session 2 on YouTube to actually get a bit more theoretical there. But other than that, I think this is This should kind of make sense. Okay. Uh, okay. And what about all the attributes that I used? So we used bins. Bins is the number of bins to use in the histogram. I said use like 50 bins. Alpha is the transparency, of course, and density true means that it is a normalization. So if let's say if I say use bins 100, okay, I'm going to make this plot a bit bigger. 20,12, alpha is 0.2, this is false. Okay, this is what happens. The value counts. Alpha 0.5 is good. Okay, so okay, so the bins, they basically are dividing the data. Okay, alpha is understandable. Density true or false uh, tells if you have to normalize the histogram or just do the value count of how many times these values are repeated, kind of. uh, yeah, if you have a smaller bin, so like the default bin is 10. Okay, this is what happens. The data is divided into like just 10 parts and it is plotted. The more you divide it, like let's say 200 pins, you are fine tuning the data. Okay, the more fine tuning you are doing on the data, and the difficult it becomes to actually visualize the whole aspect of histogram. Okay, make it a smaller data. Yes, there we go. Much better and much understandable. Sorry, give me 1 second. Okay, right. Sorry about that. Yeah. So the more the bins, the more breaking you are doing in the data. That's what it means. Lesser the bins, you're like basically doing a collection there. So, but you have to find an optimal number to actually see the histogram properly. So, example, this is following the trend. This is following the bell curve. Uh, yeah. If you divide it too much, then you get these lines which do not exactly show you a proper trend. Uh, Basically, find the optimal number is what I would say. Density true or false is between normalization uh, or the value counts. What else can I explain in this? Uh, I think this should be, yeah, I don't think there's anything else to explain here. Uh, yeah, I would say just understanding that, okay, most of the things follow normal bell curve should be good enough, actually. Like in general, it's following the trend of the whole market. But then there are these extreme events that happened, which suggest that, you know, uh, something happened in the market, which like some stocks did not follow the norm of the market. Yeah, I think that's That's everything that I want to explain in that one. What else? Uh, Analyzing correlations. Yes. So correlations, it is basically to display the correlation between different stocks. Okay, like how correlated are they? So a correlation values can range from -1, which means there is inverse correlation. Uh, Example saying that a rise in Google stock will make the Amazon, and if it correlates to Amazon stock and Amazon is -1, there is kind of no correlation or perfectly inverse correlation. Okay. Or if it's in the +1 or near to +1, it means it's a direct correlation. If Google stock moves up, Amazon stock moves up. Google stock goes down, Amazon stock goes down. So we can create a correlation matrix. This would be the last thing that we do today. Uh, this will again take in the data dictionary. And what it does, it returns underscore df is a variable that we create where we do pd.data frame, which is pandas.data frame. And inside this, we say ticker, sorry, df of return column for ticker comma df in data underscore dict dot items. Okay, so this is one line for saying that for loop for two things, for the ticker, which is the key, and the df, which is the value in data dict dot items. Choose the df return column and assign it to the ticker. And now we'll create a correlation matrix, and that is equal to returns df, which is this one, dot core. Okay, and we can print the correlation matrix. So \n correlation matrix of daily returns and print core matrix. And we can just return the core matrix as well. And now right below, let us print it out actually. Uh, let's create a variable core matrix equals to analyze correlations, and we'll pass it the data dictionary, which is our actual dictionary name as well. And just that's it. Okay. What do I? Oops, I did not run this one. Spelling mistake. Data frame. Data frame. Okay. There we go. Okay. So this is the correlation matrix between Amazon and Google and Tesla. So Amazon versus Amazon, one, which means that they're perfectly correlated. Well, it's the same stock. Amazon versus Google, it is positive side, saying that there is a slight correlation. If the Amazon stock moves, Google will move up kindly in the similar manner. Between these two, there's not much correlation. It's like 50%, less than 50%. Okay, so not really, does not matter. And that's it. That's what the correlation actually tells us. Now, I don't think this was the perfect stock or correlation matrix. It would be good to have stock, like let's say stocks in the all in the same sector, okay, or the sectors which are dependent on each other. Example, uh, Nvidia versus like Intel versus AMD versus Nvidia. Okay, so finding the correlation between them because they are in the same chip making industry, and Apple. Okay, Apple, actually not Apple because it's not exactly making chips every day. Any other chip making company. Finding correlation between them tells us that does the stock depend on how one performs versus how other performs. If let's say AMD goes up, Intel goes down, then it means that there is an inverse correlation between them. Okay, but one goes up, the other goes down, or there could be a direct correlation where both of them go up, both of them go down, goes the market trend. But that is one last thing that I wanted to show today for the time being before we end this session. The next session would be with Way actually to learn Figma and learning design with Figma, Figma for coding. So do join Way for this. Uh, if there are no further questions, I would like to end this session and let me push all of the things that we did today. Okay, perfect. All the changes that I have done have been pushed. Any questions, anyone? Okay, there is one question here. Would it be possible to overlay this on the Instagram merger? Uh, need the data actually for this, I would say. And let me copy that question, and I will try and answer this after, like, in my next session in much detailed manner. Okay. Any other questions, anyone? One last thing, as I said before, please fill the feedback form. I've shared the link in the chat quite a few times. Let me take a quick screenshot of that question. Yep. So please do fill out the feedback form and provide feedback if possible. That would be really helpful. The link is in the chat. Okay, mlh.link/GHW feedback for this session. This is the fourth session of Finance with Python. Uh, yeah, that's it. Thank you so much, everyone, for joining. And you join Way's session to learn about Figma. Okay? And I'll see you after that. So, my next session, the fifth and the last session, is right after Way's session. So, I'll see you there. Like, I'll see you back in 1 hour. Cool? Thank you so much and really appreciate it. Thanks.